Alrighty. Hello everyone. What's going on here? Fuck. Okay, Twitch, whatever. Anyway. Today. We will do a little sidestep. To see what we can do in Unreal for sound effects. I have zero idea about anything about sound with Unreal. I never did anything with sound before. So let's see how we can play sound effects and so on. What else we can do. Maybe we should start with a test level. Yeah. Let's see, play sound 2D. There. What's meta sound? And that's it. Clear sound mix class override. Clear sound mix modifiers. Clear sound. Play sound 2D. At location. What does that mean? That's very quiet. Seems to work. Man, today I'm tired. Hello, Paradigm Shift. What I'm working on, more like experimenting. My game needs sound at some point, and I need to research what the best way is to play audio. I made something simple by just playing this, but this sounds to be extremely simple. I'm sure there's a better way to do this. I could go ahead and just play one sound after the other with some blueprints, but maybe there are some features I should be knowing before going ahead and building something. But welcome! Hello, hello! Are you also a developer? Ah. Hello, Cobras. Oh. Ganz gut, und dir? What kind of game are you working on, Paradigm? Mass edits. Shouldn't I edit my stuff outside of the engine so it is already properly mixed? I wonder. Maybe this makes it easier. And, I'm not sure if you can confront me with some problems. Couple different projects with different genres, but the one is a chat game or application. I see. And why? Wait, why are you using Unreal for that? Wouldn't it be a hassle to have license and so on bound to your game? And Unreal is bloated with all these 3D rendering stuff. If you package your game, it will be like, I don't know, 2 gigabytes of Unreal stuff, and then you have like your chat system. Yeah, Cobras, I have no idea about Unreal AI. All I use is pathfinding. And that's just give me the next path, and then I just make the agents walk there. Sound cues. This not literally the sound itself, but the abstract concept of that sound. What? Ah, I see. Paradigm. Excuse me, what? Uh-huh. Cobra, I cannot watch another video right now. I'm concentrating on this part. You have to solve it yourself. Okay, should I just look into this first, what that is? Can I just create a sound cue in my content? Sound cue. There it is. Test sound cue. Now I can just do this. And then I can modify this. What? I can just play around with these things? This is a mixer? Oh my god. What? Let's see. Okay, can I then just put this into the blueprint? But how do I play around with this? Okay, let's see. Sound cue. How do I change per code these values? Oh, there it is. I can program a sound. But how do I actually manipulate it? Is this very static? Hello, baby. Welcome, welcome. Well, this doesn't help me. How about this? Sound cue. challenge, whatever. And then these are all the things inside the editor, but nothing from... okay. Unreal. Sound cue. Blueprint. Something like that. Play sound cue from Blueprint. I don't want to play it. I know how to play it. Modify our code. There we go. Okay, I have the same problem and trying to everything to fix E and E thing to fix, but now you have found a workaround. How's the monkey doing? I'm confused. I don't know how to manipulate this. I don't want to watch videos. Let's see, maybe I can just write something very simple. Unreal. Change pitch of sound. Blueprint. How about that? Change pitch sound cue while playing without starting blah blah blah. That sound, set pitch multiplier, what? Set pitch. No, it's not here. Does a pitch multiplier node not do it? I need to fire the play sound node again. Parameter. We can set a float. Can we put a float in? Also, do these have this? Set parameter. They all have it. Can I have what? Now I'm confused. How does this work? Why do the normal sounds have parameters? Ah, no, these are dude, what? Unreal sound cue parameter. How are you doing, baby? That would be 10 euros now. I see. Uh-huh. But these don't have it. What the fuck is this? I don't understand, man. What? Can I play the sound? Yes, I can. Where's volume? How do I set the sound? How do I make this louder? Hello, Hugo. Man, today I get many viewers. What's up today? Or more specifically, many chatters. Yeah, so famous. I wish I could hop in VR chat today, but sadly I have to sleep early. What did you call? Huh? Yeah, I have a dentist appointment tomorrow. Ah, I see. I don't need luck there. Just a routine checkup. Thank you. What if we doesn't change? Leave him. He's an adult. Yeah, I do. You say depends. I hate research. It's not getting louder, is it? It is getting louder, never mind. But it's not getting louder than whatever. There's a maximum near. There's no thing we can do there. Man, I have no idea. How do I make things louder? I'm so cooked. I'm so cooked. It's like there's a maximum volume where the engine just cuts everything out. I don't understand. What the heck, man? I'm so cooked. Unreal. Best practice audio. How about that? Are you fucking kidding me? No files? Just a synthesizer? How? But it's stitching together things, I guess. Okay. What is this? What type of file is this? Yeah, using fmod, that would mean I have another source or another license that I have to pay royalties to. I can't. So confusing. It's a meta sound patch. How do I output this? I would like to hear. Okay. I'm like jumping from one topic to the next to the next to the next without solving any of them. I really hate research. And another video, of course, because videos is right now the best way to understand this.
Took home the grand prize with the
Metasound editor, just to sort of orient. I'm gonna assume that people are vaguely familiar with Metasounds, but there's probably a lot of people watching this that haven't seen them, so I might be talking about stuff that's a little bit boring if you've already dove into it.
Thanks, but nope. I did not. But this doesn't seem to be that. Maybe it's this. Aha! Now there we go. Oh, I would like to play this. Yo, there's a fucking synthesizer in Unreal? I don't know how I can do things, but on the bottom right I can see that I'm changing the waveform. God, now I have to learn synthesizers. What is this? $500. 1,000. 9,999. Dude, I can make my own sound effects in Unreal. What the hell? That's why I was like, yeah, maybe I should look more into it. Now I'm glad that I jumped from one topic to the other to the other. But yeah, this is a... how to say? This is a monster that I have to learn. Oh god. Oh, square. Nice. Blah. Not good on the ears. Boop. Boop. What is this? What does that change? Type 2D rotation. Pure math. If table. No idea. Bipolar. Yes, please. Phase shift. Well, that shouldn't change anything. What's glide? I don't know what glide is. I need to change something right now. Generators. Triangle. Let's make it lower. this. Oops. That kills it. How do I mix two audios with each other? I just... crossfade. I see. I would like to manipulate that thing. Filters generate this path. Of course, there is no change here. What happens if we do an absolute value? No minus. Well, interesting. What else? What did he do? Entity. Does he have something simple we can recreate? Trigger stop after. What is that? Are these like sound samples? That can't be, right? These are triggers. This is menu, menu B. Combat, up tempo. This is music. Stereo mixer. Get, play, combat, whatever. So this is the music itself, or what? Get X. What is get X? Wave asset array. String time. Get on play. What is this? Oh, this is on play and then on finish, and do some stuff here. Apparently. Huh. it is what I thought. How do I get it in? Get wave array. And where does that come from? Input. Input something. Input. Now let's get on play. Not what we. Oh boy. Triggers here.
In this module, we'll introduce you to the MetaSounds authoring environment, which we'll review together before creating a simple patch. We'll introduce the MetaSounds editor sections, including the design canvas, the members and details inspector. We'll take a look at the default input and output events, review the housekeeping menus, and then go ahead and create our Hello World patch. Lastly, we'll have a brief introductory look at external patch inputs. So jumping across to UE5, you can see that I've already got a project open. But to show you how I did that, we can go to the new project dialog, experience, We'll take a quick tour of the various editor sections, review the built-in Metasound nodes and pins, review parameter inputs and outputs, and then create our Hello World patch. So here inside the editor, we can see the design canvas on the right-hand side of the screen. The members and details pane is on the left, and our housekeeping menu at the top for saving the Metasound, opening for new ones, playing, stopping, and reviewing various different settings related to the Metasound itself. When we create a new Metasound source, we get a number of default input and output events created. These are trigger events, so a default on-play trigger, an on-finish trigger, and an audio output, so that we can hear the patch. For our Hello World patch, we're going to create a sine wave generator, similar to the OSC object that we used in Pure Data. To do that, we right-click somewhere on the design canvas, open up the functions category, generators, and pick sine. This places a sine wave node on the canvas. You can see the inputs on the left-hand side and the outputs on the right for that node. The inputs and outputs are color-coded. Red being Boolean values for true or false, green being floating point numbers. We're ready to play the Metasound. Before you do so, please check the level of your monitoring system, headphones or speakers to make sure it's set to something sensible. There we have it, a simple sine wave at the default 440 Hz frequency. When we want to shape that continuous waveform sound, and to do that, we use an attack decay envelope generator. Right-click on the canvas, functions, envelopes, AD audio envelope. To apply the audio envelope to the sine wave generator, we must multiply its audio values. Right-click on the canvas, and this time we're going to search for the node that we want. Select multiply, the audio version. Take the output of the envelope generator and patch it into the multiplication. The output of the audio into the secondary input of the multiplication. And take the output of the multiplication and output it to the system.
Could have figured that out myself, I guess.
Default,
damn it.
This envelope has a very short attack time, so it will play almost instantly, 0.01. A 1 second decay time, so it's going to sound for 1 second. There are options to adjust the type of attack and decay curve, as well as to loop the envelope. The envelope needs to be triggered when the system starts. This is where our on-play input trigger event comes in useful, as you can see when hovering over it. Trigger executed when the source is played. We patch out of the input and drop it into the trigger input. That means that when we start the system, it will trigger the envelope, apply it to the sine wave, and we'll hear the output.
Ah. All I needed was this. Like so. This is so cool.
We can activate looping on the envelope to continuously play the sound. One of the things we might want to do is publish an input to control the frequency rate of our sine wave node. To do that, you can patch out of the input on the sine wave node and just drop it on the canvas and select the promote to graph input option. That creates a new custom input to our Metasound which we can see listed in the input section at the top. If we click on it to highlight it, we can review its details down below, change its name, see the type, the default value, etc.
Yo, what? What am I doing here? I guess.
Whilst it's possible to adjust the numeric value via a slider, it's much more convenient to use a user interface element to have it on the screen. We now have a
Knob. Slider. None. Knob. Very interesting.
knob on screen to represent the frequency input, but we need to change its value type from linear to frequency. That gives us a range of 20 Hz to 20,000 Hz, and we can reset our default value to 440. We might want to achieve a similar thing for the decay time of our envelope. Patch out of the decay time input, drop it on the canvas. Creating these inputs and they're related like it's sped up. We'll see this in more detail in later modules, but it's a key concept in our procedural audio system. In this module, we'll explore how to create interactive sample-based sounds that mirror traditional workflows in Engine. Sample-based approaches are attractive for their realistic capturing of real-world sound with a fidelity of recording such that our ears feed our perceptual systems convincing reproductions of the source material. Before we look any further into DSP-based procedural audio systems, let us first recreate a sample-based approach. It is wise to have a selection of tools at our disposal, and there may be times in situations where a sample-based approach may be preferable, or a mixture of the two will work best. In this module, we're going to explore the Wave Player node in the MetaSounds editor. We'll review its inputs and outputs, patch it up and get it playing. We'll add some looping with random start and duration inputs to add variation to the patch. So back in UE5, we're going to create a new MetaSounds source under our Module 4 directory structure. The first thing we need to do is add a Wave Player node to the design canvas. The Wave Player needs to be triggered. And you'll notice that it has a stereo output. So I'm going to go into the MetaSound settings and change the output format from mono to stereo. That gives us a left and a right output that we can patch up to the Wave Player. We can also patch up the unfinished trigger. We'll note that the Wave Player has many more inputs and outputs than the sine wave generator that we saw in the earlier tutorial. Most fundamentally, we need to give it a wave asset in which to play. We can manipulate its start time, its pitch, whether it's looping, and what the loop start and duration looks like. There are a number of trigger outputs: playing, finished, nearly finished, looping, etc. If we open the content drawer, we can see we've got an empty samples directory. We downloaded a selection of machine shop sounds from freesound.org. So I'm going to just drag those into the project. See now that they've been imported, and we can preview them by playing. We'll use this bang sample. If we keep it highlighted and collapse the content drawer, we drag out from the wave asset input and promote it to be a graph input. Select it. We can then choose a default value or a default sample to play. This button here says use selected asset from content browser. If I click it, that will use the last sample that I highlighted in the content drawer. So in this case, 511 Gen C bang. So that should be all we need to get some sound out. So let's play it and see. So you can hear it's triggered a one-shot sample, played it through once and then stopped. We might decide to loop it. We can create inputs and user interface elements to allow us to manipulate the loop start and duration. Drag out, promote to input. This time we'll choose a slider, and we'll set its range between 0 and 5. Same for duration. Drag it out, create an input. This time set the range between -1 and 3. If we play this now, we should hear that the patch remains unchanged, but we'll start to manipulate the loop start and loop duration as it's playing. By hovering over the loop duration input, we can see the tooltip that a negative value will loop the whole wave asset. Adjusting the loop start slider, we can hear the loop begins later in the sample cycle. As soon as we increase the loop duration to be a positive number, it starts at a very small amount of the sample that gets looped. We can increase that value. Another thing we might like to do is add some randomization to the pitch of the sample that's being played. Drag out from the pitch shift input and search for random. Adjust the minimum and maximum values. We need a node to trigger this repeatedly. We right click, open up the functions section, open up the triggers section. We can see that there are numerous different triggers available. We're looking for the trigger repeat. We take the repeat output to get the next random value. Trigger the repeat to start when the patch starts. So this will repeat at 0.2 seconds in terms of its period. We can adjust that value if we like. Drag it out. Okay, so what we can see is when the patch starts playing, it will initialize the trigger repeat node, which will repeat at a period specified by this knob, which is a value in seconds or fractions thereof. Every time it hits a repeat, it will ask the random node for the next random float value between -20 and 20 and send that in to the pitch shift input of the wave player. Let's have a listen to what it sounds like. In this module, we aim to create more natural sound effects by adding playback variation or selecting randomly from a collection of recordings. Sampling is a one-off process that allows us to capture realistic single instances of sound fixed in time. Real-world sounds are generally more complex, so to create convincing sonic replications, we either need to sample many variations of an audio source or try and apply creative techniques to add variations of a single sample or subset of samples. We can consider options such as layering, blending, pitch shifting, and
That's and
to unlock the true procedural audio power of metasounds, we must explore synthesizing sounds through pure DSP and modeling their behavior and attributes in our DSP graph. This requires a greater upfront investment of time, but the payoff is huge and affords a malleability of material and flexibility of interaction. As the basis for this patch, when we play up the patch and bring up the volume, is a chaotic mix of many frequencies playing switch to control the width around the highlighted frequency. In this module, we'll build out a monosynth style patch, a classic synthesizer model that plays only a single voice at a time, often used for bass lines, solos, and portamento, which is a gliding or slurring sound that happens between the pitches of each note. Classic monosynths are Roland TB303, Moog Mini Moog Model D, Korg MS-20, and Arturia Mini Brute. We'll start working with a sawtooth generator. We use an envelope to shape and modulate the frequency filtering. We'll bring in a sequencer to generate a series of notes. We use an envelope control that accounts for sequencer playback speed. We'll add some glide for portamento, pitch skewing or slurring between the notes. We'll layer extra noise and square wave generators to thicken up the sound. And lastly, we'll demo our monosynth. Classic monosynths normally have a number of generator or oscillators. We'll start by inserting a sawtooth oscillator. It has more harmonic content than the sine wave we used earlier, but less than the noise that we previously used. We'll insert a mixer. This will allow us to have control over the volume. If we open up the frequency analyzer and preview the sound, we'll notice the fundamental frequency at 440 Hz, as specified by the generator default, and an equally spaced number of harmonic partials going up the frequency range. If we switch tab to the oscilloscope, we'll see the sawtooth shape that gives name to this type of generator or oscillator. Next, we'll insert a filter to sculpt the harmonic content of the sound. This time we'll use a low-pass filter. As we decrease the cutoff frequency, we can see the partials being removed from the sound. Instead of manually controlling the cutoff frequency, we'd like to use an envelope to sculpt the timbre or colour of our sound over time. We'll insert an AD envelope, ensuring we select the float variant. The envelope has a very short attack time, almost 0, and a 1-second decay, and will output a value between 0 and 1 over its lifetime. We need to take that value and map it into the frequency range. Match out the envelope into the range. And select the minimum and output values. The input range is from 0 to 1, and the output range will be mapped to between 300 Hz and 20,000 Hz. We'll take the output of that map and patch it into the filter. And we need to trigger our envelope on play. For convenience, we'll set it to loop. And let's take a listen. We could adjust the attack time. And also the decay.
How will your Monday be, Bevy, by the way?
Note how the harmonic partials are affected over time. A classic monosynth architecture will allow you to set a base cutoff frequency and amount of envelope to apply. I tidied up the patch a little and grouped nodes into various related sections.
Some waffles.
Learn how to structure projects with clear and understandable intent. There are two types of metasound assets that we can use in our sound design. The first is a metasound source, which is the top level asset that we can add directly to our scene and can be triggered and interacted with inside our gameplay. At this level in the hierarchy, we have the ability to publish various inputs to allow wider gameplay to manipulate our metasound source. The second is a metasound patch that allows us to create custom nodes that we can reuse inside our metasound source graphs at design and runtime. A concrete example might be creating a general purpose sequencer to trigger a series of notes and play a subtractive synthesizer. We could encapsulate the logic for the sequencer inside its own metasound patch and reuse it in different metasound sources, and even across projects. To detail the different types of assets we have available, firstly we'll review the monosynth metasound source that we created in the last module. We'll highlight the reusable sequencer and AD control metasounds patches. We'll demonstrate metasound patch changes being inherited by their source parents. And finally, we'll review some sharing options. So here we have a variation of the monosynth that we created in the last module. I've saved it in the metasound sources directory underneath this module's content folder. At the time of creating the metasound source, we used two metasound patch components to aid our design. The first being the sequencer node, and the second. We can double click and go back to our monosynth and now play it. The second mechanism for interaction is to publish arbitrary metasound source inputs via blueprints, where interfaces inherit predefined game engine parameters as groups of behaviors. Publishing via blueprints allows us greater flexibility to interact with any aspect of the wider game that allows our meta to use a meta tab. And we're looking for a set float parameter node that works with audio. This has automatically pulled in the audio component underneath the blueprint, which was created from our metasound source. We need to take a reference to the metasound source parameter that we wish to update. That goes into the in-name field. We then need to create a blueprint parameter to expose that outside the blueprint. Or you can slide
I see. Now, how do I play these things though? Like, I can do this, of course. Can I even put in the meta sound? I can. And it's playing one after the other. Like if I play one, this thing is looping. If I do another, it just creates another one. Do I have to worry about the cleanups? Or does the garbage collection handle that? I don't do this looping. Can play it, but how can I play it as a audio inside a scene where I have a listener on the character that then translates that into directional sound? I mean, I probably don't need directional sound, but it would be nice to make things further away from me quieter. And I think there must be something in the engine that already does that. I shouldn't make my own system to do that. Well, it's 2 hours now. I think I will research that on my own at some point. But I don't know what we will do next time. I mean, there's so much things we could do. Sound I will probably go into when I figure out these things. and find out where to get sound from. If I need to do some other stuff, etc. And then we can add some sound into the game, I guess. I mean, for very, very simple sound effects, I probably don't even need the meta sounds, but who knows, maybe I want to do some pitch value changes and so on. And then I can just do whatever I want with that. So sound cues is the old way to do this. And now we have meta sounds that is very, very powerful, but can do the same thing as the sound cue, but in a graph, so to speak. I mean, sound cue is also a graph, but it's with very, very limited things. Huh. I guess I also have to find out how to play them as a sound source somewhere. I mean, I can put it somewhere as a sound source, I guess, by ambient sound, etc. What if I have an ambient sound? Can I then add my, what was it called? Test meta sound source? Do this. Uh-huh. What if I do this on main? Save. Sound. Ambient sound. This test. And then play. Can we hear something? I can't hear anything. I believe we are at 000, right? Seems like it. Yeah. So where is our audio? Not playing. Do I need to trigger this? Huh? Played it once. This thing also plays, but stupid. That's the thing. We always hear it. Can we do it like at an area? Ah, maybe the sound itself needs an option for attenuation. Maybe that's the problem. But now I don't hear it at all. Okay, so this breaks it. How can we set the attenuation of this? Can be? See, Unreal Meta Sound Attenuation. A video of 40 minutes again. Man.
You can hear that even though we are inside the hallway, there is no reverb, whereas if we move back here, you'll be able to hear it. Now, I'm not going to be diving into dynamic reverb. That is something that the engine is capable of. I'm not going to be diving into it in this video. That will be do any of the aesthetic going on. Meta sound. And we're going to go ahead and click on general. And over here on the left, let me actually get my camera out of the way.
Okay, whatever. I will find out at some point. But what will we do tomorrow? What should we do tomorrow? I'm really not sure. We have a world map. Should I introduce the first hub and make 3 more paths? That would be very content-y, no? I would like to make some new features. Should I try to make the Orpling Manager a 3D UI? Convert it completely? That is a huge package. Should I build a fishing minigame? I don't know. God damn it. Should I add the feeling system? I mean, it's not feelings, but targeting system maybe. So it's not always the center Orpling my guys attack, but also the side ones. But how do we change that? We give them an item or something? Like food? What else can we do? We'll look into the orb fly things and try to optimize that. Maybe we should start with that. That is bothering me so much. That they are flying so slow. Okay, I guess tomorrow we will start by polishing the Orpling flight. Maybe make it so that it's something final. Something that I can say that it should represent how it is in the final game. I'm close to it or something, I'm not sure. Okay, I guess we will do this. Anyway, Bevy. Who else is here? Are we alone? Oh, Paradigm and Hugo are also still here. Thanks for tuning in. Everyone. Thanks for watching. Thanks for the support. And I will see you guys next time. Bye bye.